Hey guys, so the last few articles I've done have been about space, which, I mean, like I've said, our planet's not going to be here very long. We might want to learn what's out there and how to get to those places because our planet in about 4.2 billion years is not going to be here anymore. So we might want a way to get off. But we're bringing it back to Earth. The deep Earth. A mysterious new substance may have been found in the Earth's core. You know, the core of the Earth that, if something was to happen to it, kablooey. Yeah, that core. You see it in like Dragon Ball Z all the time. In order to explode the planet, they send energy into the core and they just blow it up. Or they don't need it and they just blow it up with the energy itself. Either way, in fact, I wanted to read it like that. There's a lot we don't know about the Earth. Only that it's home to the greatest Z fighters the world has ever seen. No, there's a lot we don't know about the Earth. Like, how was life on Earth created? But we also don't know a lot about the makeup of the planet itself. I mean, it's kind of true. Like, how old the Earth's core is. A new study may turn everything we know about the Earth's inner core, on its head, and then make it do a backflip and toss it into the sun. John, shut the fuck up. You're fucking stupid. A new study may turn everything, on its head. Now researchers say the Earth's core isn't a solid compressed ball of iron alloy. But it also isn't a completely liquid core either. I mean, I don't think most of us thought this. I mean, I remember learning about this, and not once did they say it was solid or completely liquid. It was like a mix, kind of like magma. It's not solid, it's not liquid. I mean, considering core, that magma. So I don't, I don't know. Maybe this is new, but not liquid core either. Instead, a new study proposes that the Earth's inner core is a mushy mixture of elements like silicon, carbon, oxygen, and hydrogen. It's true. The new paper suggests the Earth's core is a mushy mix of elements. I've always in science, I've always loved seeing like a kind of like the cross section of the Earth, the inside. I would hate to be some of those mythical and legendary mole people. The ones who are buried deep in the Earth. Because the further you get, the hotter you're gonna be. Or lizard people. Aren't lizard people supposed to be living underground as well? What are you talking about, John? They're in the government. That's where the lizard people are. They're in front of us. The researchers published the paper in the journal Nature on February 9th, and it offers an interesting look into the core of our planet. Initially, scientists believed the Earth's core was composed of a highly compressed ball of solid iron alloy. Like I said, I don't remember them ever. Like, I was in school about this stuff mostly back in the 90s, and even then, like I said, the core was said or told to us like it was like magma. It wasn't solid, it wasn't liquid, but it was always, moving. And so, is this a multiple universe confirmation? Am I living in a universe now where this is unknown? I don't know. Oh my god, John, you're a time traveler and you're a space hopper. However, the findings show in the paper seem to point towards something different. The researchers note that understanding the Earth's inner core is difficult for several reasons. Well, yeah, because you really can't get in there yourself. You have to send, things on top and try to get deep. But Chief among these is the fact that seismological observations have shown a complicated structure that seems to make little sense. One of the current unresolved problems with Earth's understanding the Earth's core is that the feature is low shear wave velocity that is unmatched by the sound velocities found in iron and iron alloys. This led the researchers to believe that the core also includes light elements that lend themselves to a superionic state rather than a solid state. Researchers use computer simulations to try to understand what the core is made of. Using ab initio molecular dynamics simulations, we find that hydrogen, oxygen, and carbon, pretty much carbon makes up everything in this universe, in a hexagonal close-packed iron transform to a superionic state under the inner core conditions, showing high diffusion coefficients but like a liquid, the paper reads. Another study conducted in 2021 seems to suggest the same thing. In that study, researchers sent seismic waves through the Earth, through the core of the planet. Those waves, called shears, not those shears. Found the Earth's inner core isn't completely solid iron. Instead, it's more of a mushy substance. Of course, there's no real way to tell exactly what the Earth's inner core is without seeing it ourselves. Let's just send people down there. Oh God! Oh God! That's why the research, fortunately, sending a probe that deep into the Earth is impossible. Impossible. That's why the researchers focus on computer simulations for their latest study. Come on. I'm sure there are people on this planet who've wanted to go to the Earth's core. Some sacrifices are necessary. The superionic alloy would then allow... Oh, wait, no. Let me go back. The results of those simulations showed that the Earth's core inner core may instead consist of hardened iron. The superionic alloy would then allow other elements to slosh around. Nice choice of words. Slosh around. Essentially, the core would feature both solid and liquid states, making it even more complicated than we previously imagined. If these theories prove true, it could help us understand a lot about why the Earth's core seems to change constantly. The model could shed light on how the planet generates its magnetic field, too. Of course, the scientists will need to prove the model first, and that means waiting for the perfect moment to run more experiments and test their outcomes. For now, it is interesting at least to think that the Earth's inner core sloshing around a lattice work of superionic alloy, a consistent current of molten liquid moving within our planet. I mean, exactly, molten liquid. Liquid hot magma. I mean, I'm not the only one misremembering this, right? Basically, everything they described is what we were told back when we were kids. So, am I living in a different timeline? Is this a different universe? Because I mean, I remember we did little diorama type things of the Earth. We had them in the classroom. We saw them in the books. We read about the Earth's core and all the layers. And so am I just from a different universe? I might possibly be. Might possibly. But yeah, let me know if this was the same for you guys, because this doesn't seem like it should be outstanding, oh my god kind of news. I mean, I remember learning about this when I was a kid, that it was like basically magma, lava, You know, because that's not a solid, it's not a liquid. It's, as they say, mushy. When you think about, when you see, you know, lava coming out, you know, when you see it sliding down, it's not very liquidy. It's not just going down quickly. It kind of like glops its way over because it's mushy. It's not solid. It's not liquid. It can harden up to a liquid once it's exposed to, you know, the outside and has a chance to cool down. Yeah, then it becomes a solid. You know, and people. In fact, I wish I could find it. This cool little like statuette type thing that was made from some and ash and all that. But when it's inside, obviously it's blah 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 blah, wibbly wobbly, timey wimey stuff. No, but yeah, outside you can see it. It's like mushy, not solid, not liquid. But then once it's exposed to the outside and the weather conditions, then it starts to slow down and kind of harden up. Then it becomes a solid. So, like I said, am I just misremembering it? Am I from a different universe? Let me know. I mean, most of you are going to say, yeah, John, you're from a different universe, all right. I know you guys too well at this point. But yeah, I guess cool, I guess. Science. Anyways, you guys know the drill. I'll see you guys later. Bye, guys.